Section 1.2, Observational Studies versus Designed Experiments. We will be able to distinguish between observational studies and design experiments, and then be able to explain the different types of observational studies. Let's go over an example. Cellular phones and brain tumors. Researchers followed 79,710 women through the United Kingdom for the next 7 years. There were 1,261 cases of brain tumors. This is an observational study. So what that means is to be followed or observed, and there's no attempt to influence the individual. With observation, you can never say cell phones caused brain tumors. You can only claim association. Cellular phones are associated with brain tumors. So can only claim association. Moving on to designed experiments, we have an example. Cellular phones and brain tumors. Rats were randomly assigned. A group was not exposed, another group was exposed to GSM, and a group was exposed to CDMA. Rats were treated equally. A design experiment is the attempt to influence the individual. There are treatments that are given, such as a drug or a placebo. Next, we will go on to what a response variable is. It is the dependent variable, so that means it depends. The value depends on another variable. It is the variable of interest. And you determine how its value is affected by the explanatory variable. The explanatory variable then is the independent variable. The value does not depend on another variable. It explains the response. You can also think of it as it affects the response variable. So if you go back up to our designed experiment, let's identify what the response variable is and the explanatory variable is. So the response variable, so what are we trying to figure out? We are trying to figure out whether or not brain tumors were contracted. So that this depends on the independent. So what's the independent? Or your explanatory variable. It is the level of cell phone usage. So GSM or CDMA. With a design experiment, you can claim causation. So you can say here now that cell phones cause brain tumors if we had the evidence for it. Let's work on an example. Researchers wanted to determine the long-term benefits of the influenza vaccine on seniors aged 65 years and older. The researchers looked at records of over 36,000 seniors for 10 years. The seniors were divided into two groups. Group 1 were seniors who chose to get a flu vaccination shot, and Group 2 were seniors who choose not to get a flu vaccination shot. After observing the seniors for 10 years, it was determined that seniors who get flu shots are 27% less likely to be hospitalized for pneumonia or influenza, and 48% less likely to die from pneumonia or influenza. So what type of experiment is this? Observational or experimental design? Designed experiment. This is an observational study because right here is a keyword, after observing. They did nothing to manipulate. Next question, how could you make this a designed experiment? Well, we could randomly choose or assign two groups. One would get the flu shot and the other would get a placebo. Why do you think we should not do this? Well, think about smoking, if this maybe isn't standing out to you. Would it be ethical to tell someone to smoke and then another group not to smoke when we know it's bad for you? So it's not ethical in some cases to do a design experiment. So then when it's not ethical, we can use an observational study. Can we say getting a flu shot causes a lower rate of pneumonia? Here's the key word, causes. What kind of study was this? This was observational. You can only claim causation. So no, this is an observational study. You can only claim causation. So we could say, messing my words up today. Can only claim association. So we can say the flu shot is associated with a lower rate of pneumonia or influenza. There are other variables out there that may equally impact contracting influenza or not. What are they called? These are called confounding variables. So we're going to define that. It is an explanatory variable that was considered in the study whose effect cannot be distinguished from a second explanatory variable in the study. So some examples. In the last example, maybe the health or the age, genetics, mobility. Those are some confounding variables. Again, they may equally impact contracting the influenza or not. What is a major source of confounding? A major source of confounding are lurking variables. Think of them as kind of like hanging out in the background. But not being paid attention to. It is an explanatory variable that is not considered in a study, but affects the value of the response. So what exactly is the difference between lurking and confounding variables? Well, lurking variables are not considered in the study, and confounding variables are measured in the study.